Alright, I want you guys to compare these two lights right now. So this is the custom LED light that I built, currently running at 200 watts. That is all this light is using right now is 200 watts. That's all that my sun blaze light is using right now is 200 watts. It is 8 bulbs. So this has 8 T5 bulbs. They run at 54 watts apiece. Right now I have one of the power supplies on this light turned off so that it's only running 4 of those bulbs and only using around 200 watts. So compare the brightness of these two right now with the same amount of wattage going to each light. Okay, this one I think you would agree is clearly brighter. Let me go ahead and turn all 8 bulbs on the sun blaze using over 400 watts in this light. Which is brighter? Yeah, I think this light here is still brighter. If not brighter, it is at least a very close race. Now, I've got this light turned down to only 200 milliamps right now. And these drivers are capable of putting out 1050 milliamps. So I'm running it at 1/5 of the power right now. So let me turn it up. Okay, that's 360 watts right there. Turn it up a touch more. 370. There is 400. So this now is putting out 400 watts just like that light. Which do you think is brighter? Now, let me turn this thing up to full power just for giggles. I don't know if you can see the increase on camera, but we're now using 550 watts to this light, and these LEDs are capable of doing more than that. But I did not purchase drivers that would put out 1.6 amps, which is what these LEDs can take. So these LEDs can take up to 1600 milliamps, and these drivers are 1050 milliamps. So I did not want to burn out my LEDs quickly. Not only that, as they get hot running, even when I turn this thing up, right now if I turn it up past 200 milliamps, it does get warmer than I want it to be. So until I get some active cooling on here and get some fans to cool the heat sinks, I won't be running it past 200 milliamps. Now don't worry about the fans using very much power. You use very low voltage fans, 12 volt fans that don't consume very much power at all. But I want them on here because your LED lights will last a lot longer if you run them cool. And besides, look how much light it's putting out right now at 200 watts. So this is at 200 watts, that one's at 400. And I think that that is plenty of lights for my seedlings. Now, if I was trying to grow plants to maturity and produce fruit and tomatoes and everything else, then I might want to run this at 500 or 700 milliamps. And I would need the active cooling. Then I could do that. But for now, just growing some seedlings indoors, which is what I do, this is more than enough. In fact, I probably overbuilt this light for what I need. In fact, I would argue that these LED lights with these new cobs, the chip on board technology, I would argue that this would rival an HPS light. And a lot of your growers are replacing their HPS lights with these. And they're getting great results. Especially this light with the cobs and the power that I've got going to it. You turn this up to full speed, consuming 550 watts, is going to put out more light than some of your HPS will put out. So I could use bigger cobs, I could use bigger drivers, I could put out more light than your 1000-watt HPS. I made my own share of mistakes, so I'm going to share those with you guys as I tell you how I built this light. I do have video and pictures of the build, so I will be displaying those as I talk about it. Now, I am not an expert on this, nor am I a safety expert, so I'm not recommending that you do everything the way that I did it. I did my best to ensure my own safety when I was building this, and I would recommend anytime you're doing anything with electricity, you be very careful. So one thing you want to be careful of as you're building your light is make sure that you do not have any exposed wires or any wires that are grounded out on your frame before you go plugging it in. I will admit I was a little nervous the first time I plugged this in. So first thing that you're going to want to do is find out how big you need your light to be, how much space you need it to cover. Do you need it to just be, maybe you don't need it to be 2 or 3 feet deep, maybe you only need 1.5 feet or 2 feet, maybe you don't need 3 feet long, maybe you need 4 or 5 feet long. That's the great thing about building your own custom light is you can choose and build whatever size you need it to be. I decided to go with a 2 feet by about 3 feet. Mine is 38 inches in length. I ordered my heat sinks from Heatsinks.USA, I believe. I will post links to all the hardware in the comments and where to purchase it. So the heat sinks, you do need them if you're going to be running high capacity LED cobs like we're running here, because these are LEDs that are built right onto a board, and they were very efficient, but they can put out a lot of power and a lot of heat. So you need the heat sinks. Okay, I'm running this thing at 200 milliamps, and these cobs are rated for 1.6 amps. That's 1600 milliamps that I could put through this light, and I am at the moment putting 200 milliamps through it. I went with the 1050 milliamp drivers, so that's 1050 milliamp drivers, and I will post links to that. So I could not even run these cobs at their maximum. You don't want to. Okay, the more power you put through your LEDs, the less they're going to last. You will burn them out quick. So the great thing about Heatsink USA is you can custom order your heat sinks. You can get whatever size you want. Okay, initially I bought some heat sinks that were just 2 inches wide, and I was going to use a different LED at that point. And I quickly discovered those heat sinks were not going to be nearly big enough when I received them and I looked at them. And then I decided to go with, I think, the 4.8 inch heat sinks, and I went with that profile because it was a fairly inexpensive profile. When you go to the websites and you look at the profile of the heat sinks, you'll see what I'm talking about. But yeah, nearly 5 inches wide these heat sinks are, and I ordered them 38 inches long. The great thing is you can order them as long as you want them. I ordered 3 because I was going to do 3 different rows of lights. So you could do 1 bar of lights, you can do 2, or you can do 3 like I did. Now, to complete and make a frame for the heat sinks, I did end up purchasing some angle iron or angle aluminum that I cut into 2-foot strips that worked perfectly for bolting the heat sinks to, and made a nice little frame for the light. Now for my LEDs, I decided to go with the CX2530As. You can go with the CXB2530s. I went with the CXA2530s. The CXB is the 2nd generation. It is a more efficient LED. I don't know quite why I went with the CXAs, but I'm thinking it's because I was looking for a particular temperature. I wanted to go with a 5000K spectrum, and I had a difficult time, I think, finding that in the CXBs. I'm sure they're out there, but the CXAs are also a little bit less expensive because it's the first generation. CXBs are the newer one. So I would recommend though that you go with the CXBs. I'm kind of wishing I had. The great thing about the Crees is they look very nice. They're one of the most efficient LED, cob LEDs out there. And there's a lot of mountings and accessories for them. And they just look really nice when put together in a light. So there's a couple of different ways that you can wire your lights, and I chose to wire my lights in series. And you're going to want to find out how you're going to want to wire your lights before you buy your drivers, because you're going to buy a driver with different amperage and different voltage capabilities depending on if you're going to wire your LEDs in series or parallel. I did not need to buy drivers that could do 1050 milliamps because I don't know that I will ever run these LEDs with that much amperage going through them. I mean, I'm running these at 200 milliamps. I probably could have gotten 500 milliamp drivers and that would have been more than sufficient. So you want to figure out how you're going to lay out your lights. Make sure you're very meticulous when you mark out the holes, your screw holes for the cobs and for the cob holders. If your screw holes are off by just a little bit, you won't be able to get your screws in, and you'll have to re-drill holes and re-tap holes and all of that. So drilling out the holes is pretty simple in these aluminum heat sinks. The more difficult part is tapping the hole for your screw. So if you were going to use the Cree cobs with the TE connectivity cob holders, I would recommend that you do not use the 632 screws that I did. I would recommend that you use smaller screws. I think a 440 would be is the recommended size for these cob holders.
Okay, here's a problem I ran into, and if you learn from my mistakes, you won't make the same problem. These Lohas cobs, they had plenty big holes that I could use the number 6 by 32 machine screws, no problem. These cob mounts, the holes are not big enough for the 632 screw. You actually need a 440. The problem is my holes were already tapped for those cobs, and to prevent myself from having to tap so many more holes, I just tapped one hole for each of these cobs instead of tapping 2 new holes. The other problem is I could not find a 440 tap anywhere in my area. I'd have to order it online and then wait days or weeks for it to come. So what I did, and I don't recommend doing this because I recommend, now that you know ahead of time, that you get the right tap and screws instead of having to use these 630 screws. So what I had to do is just remount just ever so slightly the holes for these. The problem is, even though you ream it out ever so slightly with your drill bit, the copper connectors inside are very close to the edge. So you almost always end up nicking and showing some copper now inside these holes. And that's bad, because when you go to put your screws in, you're going to ground out your cob on your heatsink. That's not good. What I came up with is this Teflon tape. Teflon tape on screw. Okay, that should help prevent me from grounding out my light here. I will be checking it with an ohms meter to make sure that I do not have continuity between the cob and the heatsink, to make sure, and I'll be checking continuity every few screws that I put in.
So tapping the holes is a tricky process. Once you figure it out, it's not that hard. I recommend going slow with the tapper. You can get the little handheld tappers, which allows you to apply the power, very carefully. I did use my cordless drill. I just had to be careful and make sure I went slow. I did break several taps. I think I broke, I bought a total of 3 taps, which I broke 5 times. And that's because the taps are actually quite long. So when I broke one, I was able to take a grinder and sharpen the tip of the tap and continue using it. So just go slow when you're tapping it out. It works a lot better too if you use some WD-40 or something to make the process a little bit easier. Once you get your taps done, you can get your cobs ready, get your cob holders ready. Make sure you look at the positive and the negative on your cobs and your cob holders to make sure that you properly put your cobs in the cob holder the proper way. Because when you wire in series, you're going to want to make sure that you connect your wires negative to positive, negative, positive, negative, positive, or positive, negative. So you do not want to connect positive, positive, or negative to negative. So you've got to watch that when you're inserting your cobs into the holders and in your placement of your cobs on your heat sinks. You will want to use a thermal paste or a thermal pad. I chose to go with a thermal paste. If the thermal paste is not applied properly, you are just quite simply not going to dissipate the heat from the cob properly. If it develops a hot pocket in there somewhere because you didn't spread it thin enough or you didn't coat it all the way, you're going to have LEDs that burn out. So these are expensive cobs. You're going to want to make sure that you apply your thermal paste correctly. You do not need or want a thick layer. So you can start screwing your cob holders down, getting those cobs all in place. Once you've got that done, you're ready to start putting your wires in. So once that process was done, I figured out how I was going to mount my drivers to the light. I drilled some holes and I mounted the drivers. Later I did decide to change this because I did not want my drivers mounted too closely to the heat sinks. I wanted to put them right in between the heat sinks, not on top of the heat sinks or touching or nearly touching the heat sinks. But you want to make sure you don't overload your drivers. For example, these drivers are capable of putting out 238 volts. So each driver is going to be powering 6 of these LEDs. These LEDs have a forward voltage of around 37 volts. So if you do the math on that, 37 times 6, and actually that is just the average forward voltage. When you crank these, the power up on this, and you run these lights with more current going through them, I did put a multimeter on mine, and at full power they were drawing about 39 volts. So 39 volts times 6, you do the math, I am just barely within the range of what these drivers can handle. So you do not want to overload your drivers. Make sure whatever LEDs you decide to go with, make sure you have plenty of voltage in your driver for it to power all the LEDs you're going to connect to it. Now the LEDs are very simple to wire up. And once you get your LEDs wired up, very simple to connect them to your driver. Just make sure you're connecting negative to negative when you connect it to the driver, and positive to positive. Connecting the power cord to the driver that will plug into your wall outlet is also very simple. Make sure you plug negative to negative, positive to positive, and ground to ground. So you will want a 3-prong power cord with a ground. Wiring the potentiometer is very simple. Depending on what potentiometer you buy, make sure you take a multimeter to check the ohms on the potentiometer to make sure so that when you turn the switch on the potentiometer, make sure that your resistance is increasing or decreasing when you turn the knob, because you want to make sure that you wire it up to the correct connectors on the potentiometer. Okay, so once I got the LEDs and the drivers and everything wired up and ready to go, I gave the light a test because I wanted to make sure that it was going to work. So I didn't want to add the finishing touches if I was going to have to take it all apart. Because the next things to add are things that are going to kind of make it inconvenient to try and do further work on the light. And that was this shroud that I put all the way around the light. I wanted to go with something inexpensive. I've already spent a lot of money at this point. So I spent less than $8 on this shroud. I can't remember exactly how much it was. But I went to my Home Depot and I looked through all the materials that they had, and I kind of had in my mind what I wanted. And what I actually ended up getting was some material that it actually is for roofing. I'm trying to remember what it's called. I can't. I'll put it on screen right here. Anyways, one of the reasons I really liked it is because it had a nice lip and a nice little angle. It didn't have sharp edges. I didn't want anything with sharp edges. And I knew that I would easily be able to cut it with some 10 snips and bend it into the shape that I would be able to put it on my light and have it look decent. So you could do it however you wanted. You don't have to do a shroud. You can do sort of a boxy light look, which Grow Mouse built on his channel. I'll put a link to his build as well, because I don't want you guys to just look at my build and the way I did it, because I learned from these guys. So take a look at it when you're done with this video. Take a look at Grow Mouse's video if you are serious about doing a build. And Green Jeans Garden, he also was nice enough to do a grow light build on his channel. Once I had the shroud done, it was time to do the cover, to go over the wiring and sort of give it a nice, clean, reflective look, so that when light from the LEDs got reflected back up into the light, that it would get reflected back down. So this sort of panel or cover, and not only does it make it look nice, but it does provide some functionality in reflecting the light back down that gets reflected up.
Okay, here's the light finished, completely finished in all its glory. I got the panel cover on here. Now this is not aluminum. It would have cost around $40 to have a aluminum panel. So I've got this out of the heating and ducting area. So this is basically just ducting material that I picked up for $16. It was a pain in the ass to cut, so I got these nice little round, I don't even know what to call these, but I got them from the electrical department, and they're just these little discs, and I decided to epoxy them to the sheet, and it's just a JB Weld epoxy, so I don't think there will be any complications from that. But I did screw the panel in. There are spacers underneath these screws, about 1/4 inch spacers, to hold this panel off of the heat sinks. And so that's it. It's beautiful. I'm going to go ahead and light it up right now for you guys. And that panel, I think, is going to be nice. It's nice and shiny. It's going to reflect any light that is reflected back up into the panel. And so I'm really happy with that. I'm really happy with these Cree lights as well.
So the mistakes I made was initially not knowing what LEDs I was going to go with, and going with these LEDs that didn't look nice. They didn't have any nice holders or covers that would cover up the soldered wires and everything else. And the other mistake I made is not knowing enough about the drivers and the fact that I needed a 100K potentiometer for that dimmer. Because if you go throwing a 10K potentiometer on it, you're only going to be able to run that driver at about 1/10 its capacity. And that's a mistake that I made. When I initially turned this light on, it was not very bright at all because I was running it with a 10K potentiometer. So I was putting 100 milliamps through it. And I was very disappointed. I thought that I had put together a piece of junk. And I ran it that way for a long time, thinking that was all the power that I could get out of it. And then I got to researching, I got to using my multimeter on things and thinking, how is it possible that this light is only running at 100 watts, right? And so that's when I discovered I needed the 100K potentiometer. So just pay attention to the little details like that and you'll be fine. Because with the 100K potentiometer, I can now run this up to full power if I want to. Also keep in mind that I'm running this at 200 milliamps, and that is because it would get too hot if I ran it any more than that without some active cooling and some fans. I will bring an update on that as soon as I get the active cooling on here. With that being said, at 200 milliamps, this really is putting out more than enough light for these plants. Okay, if I turned it up, I'm thinking I would probably need to raise the light higher, which would be great if you needed to cover more surface area. But why waste the wattage if you don't need to run the light that high? So take into consideration that you may not need drivers that put out an amp of current. Okay, you could go with 500 milliamp drivers, and that is going to be more than sufficient because I'm using 200 milliamps. Okay, when I get the active cooling on here, I may run these at 500 milliamps. Okay, and at that, I'm probably going to use 400 watts. So I believe I did make a mistake in purchasing drivers with more amperage than I need. Also, because I didn't like the original LEDs that I got, I had to take the light apart and put it back together again, at least as far as the LEDs are concerned and the wiring and everything. So the LEDs, of course, were different sizes and the holes didn't line up, so I had to re-drill and re-tap holes. So make sure you know what you're buying and that it's going to work for you before you buy it, so that you don't end up having to take parts off and then you have these parts lying around that you're not using, and then you have to re-drill holes. These are the mistakes that I made. So figure out what you want, what's going to work for you. Plan it out really well before you start building it. And if this is the first build that you've done, things are likely to go wrong. Unless you do plan on building something very similar to what I did, or what Grow Mouse, or what Green Jeans Garden built. So that's it. That's all I have for the first Grow Light episode. If you didn't see my episode on choosing a grow light and the perfect spectrum, check out that video, because you're going to have to figure out when you're buying your LEDs what spectrum you're going to want. Are you going to want 3000K, 4000K, 5000K, or 6500K? Everybody seems to think you need 6500K for veg. That is not necessarily true. If you watch the previous video, that will be explained. If you watch Green Jean Garden's videos and his tech talks, you will understand you don't need 6500K. Each plant, depending on what you're growing, might respond differently to different light spectrums. Not every plant is going to respond the same to 6500K. The pigment, the color of the plant leaf will actually change and determine what spectrum it responds best to. So that's something you have to consider when you're buying your LEDs and you're buying your parts for your light. What temperature you want to get, what spectrum, what light spectrum you're going to use. So it takes some planning and some thought to do it. But I want to thank you guys so much for joining me on this episode. I've enjoyed putting the light together. I've enjoyed bringing you guys the information. Thanks so much for your support. Any comments or thoughts? If you plan on building your own light especially, let me know down in the comments. Let me know any way I can help you out. Thanks for watching.